Okay, so paper 1 from your mock exam. So this is the non-calculator paper. Let's see how we get on. So first question, expand and simplify. Well, expand basically just means multiply out the brackets. So we've got 2m minus 6 plus 3m plus 12. So that's the expansion done. Now just collect the like terms. So we've got 5m plus 6. So first question done. Next question. Scatter graph shows the age and value of each of 10 cars of the same make and model. Describe the relationship between the value of the car and the age of the car. Well, you could have written as the car gets older it's worth less, or you could just write there is a negative correlation. Okay, so draw a line of best fit on your scatter graph. So best fit, ideally same sort of number of points either side of the line. So something like that. Okay, not necessarily all the way down here either, because we get a bit out of range here. It may not be reliable to use the line of best fit to predict the value of the car that is 10 years old. Well, that's because it's out of the range. So it's out of the range of the scatter of the line of best fit. So out of given range. So any comment relating to its being a long way away from these points, the oldest car we've got here is 7, obviously 10. It's not going to be worth less, is it? So out of given range should be sufficient for those marks there, or that mark, should I say. Okay, next question. So there are 270 students in year 7. Each student studies French or German or Spanish. 2/9 study French. The number who study French to the number who study Spanish are 3 to 7. 42 boys study German. So what percentage of boys? So we need to work out how many are studying German in the first instance. Well, let's work out what 2/9 of 270 is. Or 270 divided by 9 is 30, times by 2. So there are 60 who are studying French. Okay, now let's use this ratio of 3 to 7. So we've got French to Spanish, which is 3 to 7. Well, at the moment we've got 60 doing French, so that's a multiple of 20. So if we times that by 20, we'll keep them in the same ratio. So we've got 140 students doing Spanish, which means out of 270, there is a total of 200, so we've got 70 students are studying German. Studying German, always a good idea to say exactly what you've worked out, so it's easy to see. And we just want to work out percentage of boys, so we've got 42 out of 70. Okay, well that's not an easy percentage to do at the moment, so let's have a look. If we divide the top and the bottom by 7, we get 6 over 10. So actually your answer is 60%. 6 out of 10, we could scale it up and put it out of 100 if we wanted to. Okay, so far so good. Number 4. Here are the front elevation and side elevation of a solid prism. So that's from the side. That's from the front. Okay, so it is 4. So it is actually 4 by 4. On the grid below, draw a plan of the solid of the prism. Well, it is because the side elevation is 4 long and the front elevation is 4 long. It's basically going to be a 4 by 4 square. Now, there's something we need to probably mark on there because there are changes in heights, because it's got this slopey roof. So in the middle, we need to draw a line. So actually, It doesn't actually matter whether we do it a vertical line or horizontal, but that would mark this point here. Now, in the space below, draw a sketch of the solid. So that's the side, that's the front. So actually it is, we can do a prism with our pentagon at the end. So here we go, very badly drawn. But really they're just judging to see whether you can picture the shape. So the shape is going to look like that. Not quite dimensionally correct because this should be the same length as that. But you get the idea of what the shape is going to look like. So that's our solid prism drawn. Question 4. So let's go on to question 5. Right. Diagram shows a block of metal on horizontal ground. The base of the block of metal is a rectangle 20 by x. The block exerts a force of 1,500 newtons on the ground. The pressure on the ground is 3 newtons per centimetre squared. Work out the value of x. Well, they've very handily put this formula in here. So we know we've got pressure of 3. So we know 3 is equal to exerts a force of, so we know the force is 1,500, but we don't know the area. So we could actually use this to work out the area, which will then allow us to work out what x is. So our area, and it is, all the units are going to tally up because we're in centimetres squared, we're in centimetres here, is 1,500 divided by 3. So we've got 500 centimetres squared. So basically this rectangle at the bottom is an area of 500. We know one side's 20. So it's 500 divided by 20, which is going to be 25 centimetres. So x is 25 centimetres. Make sure you make it nice and clear, but I think we can see from that what we've done. Okay, number 6. Write 247,000 in standard form. Well, standard form's got to be between 1 and 10, so it's going to be 2.47 times by 10. How many powers of 10 are we going to need? We're going to need 5. So 2.47 times 10 to the 5. But I think you pretty much all got that anyway. Now we're going to write 6.5 times 10 to the minus 4 as an ordinary number. So we're going to divide it by 10 4 times. So 0.000, that should be a 0.65. Okay, so 0.00065. Now, work out your answer in standard form. Let's get rid of that one. So we can multiply. So 3 times 8 is 24 times 10. We can add the powers, which gives us minus 13. Okay, that's not in standard form though, so we've got 24 here. So basically we need one less division of 10, so it becomes 2.4 times 10 to the minus 12 because it's the negative one, so it increases to minus 12. Okay, so number 7. Now number 7 gets a bit wordy, so let's see what we've actually got. We've got a diagram for trapezium and a square. AD is 10, DC is 3 times AB. The perimeter of the square is 24. So actually the length of one side is 6. So basically 24 divided by 4 gives you 6. The area of the square is half the area of the trapezium. Right, well, area of the square is 36. So therefore the area of the trapezium is going to be 72. So now all we need to do is use our formula for our area of our trapezium to work out the length AB. So area of a trapezium is the parallel sides added together divided by 2 times by the height. So we've got AB plus, now this is 3 lots of AB. That all has to be divided by 2 times by the height, and that's all going to equal 72. So let's have a little tidy up. Well, AB plus 3AB is 4AB, but I'm going to divide it by 2, which gives me 2AB times by 8 equals 72. Well, these are multiplied, so actually this is 16AB equals 72. So now I just need to do 72 divided by 16. Oh, I don't know why I've written that there, sorry. So 72, it's all going so well. 72 divided by 16. Well, if you know your 16 times table, well, you might not, but 5 lots of 16 is 80, and that's half. So actually, you could actually just write out 16, 32, 48 and work it out that way. But AB works out at 4.5 centimetres. Okay, so that was question 7. Let's have a look at question 8. Right, don't particularly like this question, but work out the estimate for the value of 58.7 squared and the square root of 1612. Right, so I am going to do 60 squared and the square root of 1600. Now I know you would normally round this to 2000, and you won't be wrong if you have done, but it just makes it a lot harder because actually we know the square root of 1600, or hopefully we do. So 60 squared, 6 times 6, and then my 2 zeros, and then the square root of 1600 actually is 40. So now we can just do a fairly straightforward calculation, 360 divided by 4, which is 90. Now, is your answer to part A an underestimate or an overestimate? It is going to be over, and it's going to be over because you rounded up the top. So you rounded up the, let's actually use the correct mathematical name, numerator, and you rounded down the denominator. So that will make it an overestimation. Okay, now question number 9. A company has a target to reduce the number of its stores by 40% over the next 2 years. At the end of the first year, it has reduced the number of stores by 20%. If the company is going to reach its target, it must reduce the number of its stores by another P% in the second year. Okay, so if we're working on percentages, say we started with 100 stores. At the end of the first year, we're reduced by 20, so we've got 80 stores left. But actually, a 40% reduction, we want to end up with 60 stores. Well, if I now have 80 and I want to get to 60, it's not 20%. I need to lose another 20 stores, or 20 out of 80 is actually 25%. It's a quarter of it. So the value of P is 25%. If it goes down 20, the next year it would have to go down 25%. Okay, let's have a look at the next question, number 10. Here are the ages in years of 19 men in a badminton club. Okay, now we need to draw a box plot? Well, we can do 22. Check the scale. Each little square is 1. So 22, lowest value, 58, highest value. So we dealt with those. Now we need to find the median. Well, if we've got 19, the middle value is actually going to be the 10th value, because basically you would add 1 and half it. So 1, 2, 3, 4, 5, 6, 7, 8. Could have done that without actually doing that. But anyway, 38. So your median is there. So that's going to be the line in the middle of your box. Now we need to do the lower quartile, which will be at the 5th person. So it'll be at 32. And then count in the 5th person from the top to get the upper quartile. 1, 2, 3, 4, 5, 47. So 3 squares down to there. And complete your box. That's the middle 50%. Then complete your lines out to the highest and lowest. Right. We can now make a comparison. Compare the distribution of the ages of men with the distribution of the ages of women. It's worth 2 marks. So we need to make 2 points. So, men on average are younger due to having a lower median. So that's one comparison. Now we can compare, let's have a compare how spread out they are, the distribution. So actually, the men's ages are more spread out. More spread out. Men's interquartile range, I think, is it's from 32 to 47. So that's 15. And it's quite often a good idea to put some values on here. The women's interquartile range is going to be from 37 to 49. So actually, interquartile range of 12. Okay, so it shows the men's ages are more spread out. Right, let's see what we've got next. Number 11. We've got boxes of chocolates, large and small. Okay, straight away you can see you've got 2 statements with 3 small, 1 large, 1 small, 2 large. So we've got simultaneous equation. So 3, or we will have in a minute, 3 small boxes plus a large is equal to 66. And 1 small, don't really need the 1, sorry, plus 2 large, 72. Now we'll use the elimination method. So I'm going to double the top one. I'm going to times that one by 2. So I've got 6s plus 2l is 120/32. I'll write out the other equation underneath again. Make it all nice and neat. I'm going to take them away because they're both plus 2l's. I've made the coefficient of the l the same. So I'm going to take it away. Not very straight line, sorry. So I've got 5s, 2l take away 2l goes, and then I have got, that gives me 60. So 5 times something is 60, so s is 12. And once I've worked out s is 12, I can substitute it back in here. So that make that 12. So 2l is 60, so actually l is 30. 12 and 30, and you can check it on the other one if you want. 3 times 12 is 36, plus 30 is indeed 66. Right, so far so good. Now, work out the value of... So we've got to do some multiplying of surds. We've got root 7 plus 5, and you've got to treat it like double brackets because it's all multiplied. Okay, so I'm just looking at the top at the moment. So root 7 times root 7 is 7. I've then got root 7, so I've got minus 5 root 7. I've then got plus 5 root 7, and the 5 times 5 gives me minus 25, which all simplifies. They actually go, so I've just got minus 18, but mustn't forget on the bottom, so I've multiplied the top, I've got minus 18, but then I need to do 3 times 3, which gives me 9, so my final answer is minus 2, because I've got minus 18 divided by 9. Right, number 13. Julie has to solve. Here is her first line of her working. So she's using the quadratic formula. Hopefully you can remember the quadratic formula. Minus b plus or minus square root of b squared minus 4ac, all divided by 2a. Now, first line Julie's working is wrong. Why is it wrong? Let's have a look. So what she has done with this bit here, it's minus b, and actually it's already a minus b, so it should be, it needs to start with a positive. So it needs to start with a positive 5. Because actually you've got the double negative there, double negative there, which means that should be a plus. Right, that was fairly straightforward. Number 14. Rachel has 10 sweets. 7 of the sweets are yellow, 3 of the sweets are red. Rachel takes a random sweet from the bag one at a time until she gets a red sweet. She does not replace the sweets that she takes from the bag. Rachel stops as soon as she gets a red sweet. Work out the probability that Rachel takes no more than 3 sweets. Right, well, she could have a red, and if she picked a red the first time, that would be it. She wouldn't pick any more. Probability of just a red is 3 out of 10. Now, she could pick a yellow the first time and then a red. So yellow the first time, 7 out of 10 times by 3 out of 9. She's not replacing the yellow one. So that gives us 3 over 10. This gives us 21 over 90. But she can do it 3 times. So she could pick a yellow, and then a red, which is basically going to be 7 out of 10. She's already picked a yellow, so now it's 6 out of 9. But the third go, because she only goes up to 3, she gets a red. And we get that. Okay. And let's see what we can do here. Let's do a bit of simplifying before I start multiplying all that out. So I've divided that by 3. Let's divide this by 2. And now we've got 21 over 120. And we need to somehow add these all together. Right, let's try 3/10 plus 21 over 90 plus 21. And remember, we've got to try and get a common denominator. Well, I think probably getting a common denominator, make it out of, because this, so I'm just going to do a little jotting here, 21 over 90 is the same as 7 over 30, basically divided by 3, which is the same as 28 over 120, times them by 4. So I've got 21 over 120, I've got 28 over 120, make this one over 120, so times that by 3, all the same now, so add them together, and I think that gives me 85. 85 over 120, which is absolutely fine as an answer. It does simplify. If we divide through by, let's have a think. If we divide through by 5, we end up with 17 over 24. But it doesn't say anywhere you need to simplify, so that would have been absolutely fine. Right, number 15. Make x the subject of the formula. Right, okay, so slightly different. We've got the x squareds in there, but we follow through exactly the same steps. So let's get this up here. So I'm going to multiply by 2x squared plus 1. No, it's all going so well. Right. And that's still equal to x squared minus 3. So let's expand that, see what we've got. Now I want to get all the x's on one side and everything else on the other. So I can, let's go for a 2x squared y minus x squared. And then my plus y is coming over here, so I end up with minus y minus 3. I can now factorise, so take my x squared out. So I've got 2y minus 1 minus y minus 3. So x squared divide by this. Now you can do it the other way round. Okay, now I just need to square root at the end. And I'll explain what I mean now. If you collected the x squareds on the other side, you would have a plus y, a plus 3, a minus 2y, and a plus 1. Exactly the same answer, you get the marks either way. Right. Next question. Let's have a look. So, we've got a, b, c, d are integers. 4a equals 5b, c is 3/4 of b, a to d is 3 to 5. Find a to b to c to d. Right, okay, so let's have a think. Firstly, b is equal to 4/5 of a. Basically what I'm going to try and do, I'm going to get it all in terms of a, because I think I can do that. So if we're working the ratio of a to b to c to d, we also know that c is 3/4 of b. So let's see how we go. A to B to C to D. So we know if A is 1, B is equal to 4/5 of A. So keeping it in the same ratio. So 1 to 4/5, that works. Now we know C is actually equal to 3/4 of B. Well, we know B's 4/5, so actually 3/4 of 4/5 is 4 out of 5. So we only need 3/4 of that, so actually that is 3 out of 5. Okay, now what can we do with D? We know, I'm just going to write it down here so you can see, we know A to D is 3 to 5. I'm working on A being 1. So if I divide these both by 3, I get 1 to 5 over 3. So now I've got it in the ratio of A to B to C to D, and they're all fitting as per instructions we've been given, but they're integers. They're not integers. So I need to find a number that I can multiply them all by to get rid of the fractions. Well, I've got 5s and 3s as the denominator, so 15 is the logical number, because if I times that one by 15, 1 times 15, 4/5 times by 15 is just like timesing the top by 3. 5 goes into 15 3 times, so that's 12. Same with this one, that's 9, but now I'm going to have to times by 5, because 3 goes into 15 5 times. So I've got 15 to 12 to 9 to 25. Okay, and they're all in the same ratio as per the instructions we were given. Right, quite like that question. Question 17 looks like a circle theorem question. we've got A, B, C, D on the. So we've got cyclic quad going on here. The size of angle ABO and ODA are 2 to 1. So in other words, this one here is 2y because it's twice that. Find an expression of 4y in terms of x. You must show all your workings. Right, okay, so let's have a little think what we can do. We've got quadrilateral here. And actually, we know that angle there is 6x because it's double the angle at the circumference. It's at the centre, so we can call that 6x. And this one here, we can, because this is a quadrilateral in a circle, we've got 180, take away 3x. Now, we can now form our equation because we know all four of these angles add up to 360. So 2y plus y plus 6x plus 180 minus 3x, and that's all going to equal 360, number of degrees in a quadrilateral. Let's have a tidy up. So we've got 3y plus 3x. I'm going to take away the 180. Right, and we need an expression for y in terms of x. So let's divide through by 3 because it goes into everything. And I need it y equals 60 minus x. Okay, and actually now we've got our expression. Y is equal to 60 minus x. Or actually our expression 60 minus x. So, that was number 17. See what we've got now. Number 18. Factorise fully. Okay, well we've got some squares here. And we've got a 3 and a 12. So the first thing we can do is take the 3 out. And then see if there's anything we can do. Well, we can because this is the difference of two squares. That's a square number. That's a square number, so we've got the 4 there. So we can do 3x minus 2y. Hopefully you can remember doing these. X plus 2y. And actually, if you can remember that, it's quite a nice 2 marks. Let's have a look to see whether 19 is just as nice. Okay, so we've got 12 to the minus 3 over 2. So we've got, straight away I would deal with the negative. Negative power means it's 1 over. So now I've got 1 over 12 to the power of 3 over 2. Well, that is the same as 1 over, because it's the power of a half, I can split this to a half and cubed. So I've got square root of 12 cubed, and notice the square root is quite handy because I've got square root in my answer up here. Now, square root of 12 is actually equal to 4 times 3, which is 2 root 3. Again, notice my root 3, we need a root 3 in the answer. So, cubed basically times by itself. So we've got 1 over 2 root 3 times by 2 root 3. They're making you work for this one. 2 root 3. Well, 2 times 2 times 2 is 8. Root 3 times root 3 is 3. And I've got my root 3 at the end. So I, oops, sorry, forgot my 1 on the top. So now I've got 1 over 24 root 3. Multiply those together. Now, unfortunately, that is not that yet. But because we've got a third at the bottom, what we can do is rationalise the denominator. So they are actually asking quite a lot on this question. So I'm going to multiply it by root 3 over root 3, which gives me root 3. Hopefully, we've just done root 3 times root 3, which is 3. So 3 lots of 24 is 72. So what are we trying to find? Where h is the integer? Well, we've got it in the form that we wanted. So h actually is 72. and we've got it in the form thereafter. So quite a bit there, but actually 4 marks towards the end of the paper. I'm going to have to work for it. Number 20, what have we got? So we've got our sine curve. Okay, good. But it has a -2 on the end, which basically is a transformation. It means it's moved down 2. So each point has moved down 2. It's not in the brackets, it's just on its own at the end, so that is fine, assuming I get it in the right place. Okay, so now we just need to nice smooth curve, and we've got our curve drawn. Now, the exact value of cosine 60 is 0.5. Oh, they've given us the cosine curve. Good. So the exact value of cosine, so basically there. So that's 60. That's 0.5. Write down the exact value of cosine 300. So 300 is actually over here. Now, because it's symmetrical, about 180, that is the same distance as that, so 0.5. Okay, so the exact value of cosine 300 is 0.5. Now, write down one solution of the equation. So now we're at minus 0.5. Well, this distance here was 60. So from there to there is 60. So actually that is going to be 120. Alternatively, you could do this one here, where you've gone a bit further, which is basically another 60 onto the 180. So you could have had 240, but you only need to put in one value. We will be spending some time on this term. Okay, so we must nearly be finished. 21, right. Well, we haven't done vectors yet, but let's have a look what we need to do. The diagram shows the lines OX, OY, OZ. Okay, we've got our vector Z. Determine whether or not X, Y, Z is a straight line. Okay, so what you need to do, we firstly need to work out X, Y. So in other words, to get from here to here. So I'm basically going down there and up there. So I've got minus 5a plus 3a. That is minus 2a. I've now got minus b, because I'm going the wrong way, so you have to make them negative. So minus b plus 2b is b. Okay, now I'm going to do, let's do y, z. I'm going to do all three, probably don't need to, but we're going to. So I've got minus 3a minus 2a, so that's minus 5a. And then I've got minus 2b plus 3b, sorry, plus 5b, which gives us plus 3b. And then I'm also going to do xz. So basically I've got minus 5a minus 2a. I'll explain what this is going to show in a minute. Minus b plus 5b, so it's plus 4b. Now, if this was a straight line, these would all be multiples of each other. Okay, and they're not. Okay, if I multiply this by 2, for example, I would have 4a and 2b. I have, or minus 4a plus 2b. I haven't got that anywhere. So these are not multiples. So therefore, it's not a straight line. They are not multiples of each other. That is one more topic that we need to do. So that was question 21. Oh, it goes on, doesn't it? 22. Right, what have we got now? Okay, we need it in completed square form, but we have a 3 here at the front. So the first thing I would do is take the 3 out. But I only do the first bit. So I'm going to leave the 38 alone. can do that, but 3's into 38 doesn't go very well, so let's leave it like that. I'm now going to complete the square. So I've got x minus 4 squared minus 16. Notice I've introduced the square brackets now. It's just to make sure I don't forget to times this by 3 when I take it out. But obviously I've half that, got my negative power, which finally gives me, I want to get it in the form that they've given it. 3 lots of 16 is minus 48, so it gives us minus 10. So we know that A is 3, B is 4, C is 10. Hence or otherwise, write down the coordinates of the turning point of the graph. Well, we've actually done the hard work because we can just read it off here. So the turning point is 4 from inside the bracket. Remember, you change the sign. You basically put the bracket equal to 0, but the minus 10 can actually just be written down. So the turning point is 4 minus 10. And then the last question, what have we got? So we've got a circle. I am going to draw a little diagram, I think. Center 0, 0. So we've got our circle. L is a straight line with a negative gradient, so it's going down like that. C and L intersect at the points A and B. A is minus 9, 2. So that's minus 9, 2. That's A. And B is 7 something. Right. Well, okay. It's got a negative gradient. So let's actually put B there. That was just 7, wasn't it? Find the equation of L. So basically the line joining these up. Okay, but we can't do that because we're missing a coordinate here. We only know this is 7 question mark. But we do know the equation of the circle. So the equation of the circle is x squared plus y squared equals r squared. But we know it goes through this point here. So we can do 81 plus 4, which therefore gives us 85. So now we can use this with our other value. So we know that, well, we got 7. No, it's not working. That's rather annoying. So we've got 7 squared. Let's try again. We've got 7 squared plus y squared, which we don't know what it is, but we do know that that is equal to 85 because it's on the point on the circle. So y is equal to the square root of 85 minus 49, because I'm taking it over the other side. Let's hope that works out nicely. That does. That gives us 36. So y is either plus 6 or minus 6. Remember, when you square root, you've got your plus and your minus. Well, it's got to be the minus 6. So y is minus 6, because otherwise we'd have a positive gradient and we're told it's negative. So that is there, 7 minus 6. So now I've got 2 points. I can work out my equation of my line. So m, so let's work out the gradient. We've got minus 9, 2. So basically we're just doing the equation of a line through these 2 points. There's quite a lot to this question, isn't there? So we've got minus 6 minus 2. So difference in y over the difference in x, which gives us a minus 4 over 6 and minus a half. We can use y equals minus a half x plus c. So let's use this point as that's the one they gave us. We've got 2 is equal to minus a half times minus 9 plus c, which gives us that's 4.5. This is all just to work out the value of c. So c, I think, is minus 2.5. So the actual equation of the line is y equals minus a half x plus minus 2.5. Don't really want to mix my decimals. 9/2. That's not 9/2, it's 5/2. And that's actually the equation of the line. Okay, so y equals minus a half x minus 5/2. So we use the equation of the circle to work out our missing points. Once we had our two values, we used those two values to get our gradient. Once we got our gradient, we used y equals mx plus c and used our point here to work out the value of c. And that is paper 1 completed.